Okay, here we're going to start solving questions on the practice test for Unit 7, the limiting reactant and percent yield. Number 1, in a certain chemical reaction, copper 2 chloride reacts with sodium nitrate to produce copper 2 nitrate and sodium chloride. 2,000 grams of copper 2 chloride are reacted and 1,600 grams of sodium chloride are produced. What is the actual yield of sodium chloride? What is the theoretical yield of sodium chloride? And what is the percent yield of sodium chloride? Okay. First things first is looks like we produced 1,600 grams. So what is the actual yield? That's easy, 1,600 grams. What is the theoretical yield? Okay, so if we have 2,000 grams of this stuff, we are interested in what is the theoretical yield of that stuff. So this is going to take a little bit of stoichiometry, but it's pretty simple. I mean, at this point it should be. So we have 2,000 grams of CuCl2. Let's convert that into moles. You always got to convert it into moles, and this is how you do it. Copper, all right, I'll get the periodic table out. Copper is 63.55, so 63.55 plus 2 chlorides, so that's two 35.45s, 35.45, and that is a total of 134.45. So 134.45 grams or 1 mole of copper chloride. How do you know that this goes on the bottom? Well, because this unit grams of chloride went on the top. So they have to cancel each other out, leaving only moles. And the answer there is 2,000 divided by 134.45, 14.88. I am rounded to the hundredth, so 14.88. 14.88 moles of copper chloride. Well, again, we are interested in how much sodium chloride we should get, so we got to do a molar ratio. That's our next step. It is already balanced, so it is 1 mole of copper chloride will produce 2 moles of sodium chloride. So I'm just going to take that 14.88 and multiply it by 2. 29.76. That's how many moles of salt or sodium chloride you should get, but we're interested in the grams. So one more step, we got to convert that back down to grams. Sodium is 22.99, chloride is 35.45. That's 58.44. So 58.44 grams for 1 mole of NaCl. How did I know that it was set up like this? Well, you have moles there. You got to have moles in the bottom. So 29.76 times 58.44, 1,739.2. 1,739.2 grams rounded. Okay, that is how much we should have gotten. What is the percent yield? So we're going to take our actual and divide it by our theoretical. So that is 1,600 divided by 1,739.2. Hit enter. Looks like 91.996. So that's going to be we'll call this 92%. 92.00% yield. And that is how you do problem number 1. Okay, here's number 2 on the practice test. 25 grams of sodium iodide are reacted and it produces 28.15 grams of lead iodide. What is the percent yield of lead iodide? Okay, so again, important to understand what's happening here. We have 25 grams of this stuff, and we are interested in how much of this stuff we're supposed to produce. And then we can figure out how much we're supposed to produce and then compare it to how much we actually produce. And that's basically how you do this question. So we got to get 25 grams of this sodium iodide and convert it into moles, and then do like some stoichiometry. So here we go. 25 grams of NaI. Now we got to convert that into moles. So 1 mole of that stuff is, so we got to add up the pieces now. So 22.99 plus iodide is 126.9. 149.89. So 149.89 grams. Again, if you got grams on the top, you better have grams on the bottom to get the correct units. So 25 divided by 149.89 is 0.1668. I'm just rounding to the 10,000th just because the number's so small. So 0.1668. Okay, and now we got to do the molar ratio between those two. And this is a 3 to 1 ratio. You know that the 3 has to go on the bottom because, again, the units have to cancel correctly. So I'm going to take this number, divide it by 3. Because my calculator still has the exact number before, and this number right here was rounded, might be slightly different than what you see on your calculator, but so we have 0.0556 moles of PbI3. And got to convert that to grams. One more step. PB, so lead. Lead. Where are you, PB? I'm wasting time looking for you. Wait, what the heck? There it is. It's atomic number 82. So 207.2 plus 3 iodide. So plus 3 times 126.9. This is going to be a big, heavy molecule. 587.9. So 587.9 grams for 1 mole of that stuff. Again, we know that the units have to cancel. So times 0.0556, 32.69. So you should produce 32.69 grams of this stuff. Right? This would be your theoretical yield. Theoretical. Your actual yield was the 28.15. So to get percent yield, we're going to go 28.15. We're going to divide it by what you should have gotten, your theoretical yield. 28.15 divided by 32.69. And it looks like 86.11%. 86.11% yield. And that's how you do question number 2.